Welcome to this M2 Technologies tech tip showing how to limit spindle RPM. This Edgecam technology ensures that spindle speeds and feed rates stay within acceptable ranges, which are specified by the cam user. The part for this training exercise has tool path created. Let's open up one of the drill cycles. Notice that the spindle speed is 22,000 RPM and the feed is 70 inches per minute. The machining center that we're going to use for this application only has a 10,000 RPM spindle. And so the problem that we have here is the user has input a spindle RPM that exceeds the machine's capabilities. Since the machine capabilities are input into the post-processor, let's see how the apply speed capping option can keep speeds and feeds within the machine range limits. As a side note, by default, the apply speed capping option is turned on in any sequence created. When I press OK, Edgecam is going to go rebuild the tool path, and we'll notice some notes come up in the feedback window. Those notes inform us that on instructions 11 and instruction 16, the spindle speed is greater than the max RPM of the machine, and so that not only has spindle speed been reduced, but also feed rate. If we take a look at the same drill cycle, notice that the spindle speed is now capped to the limit of the machine, 10,000 RPM instead of the 22,000 that was in there before, and that the plunge feed has been moved appropriately as well so that the chip load and the relationship between feed and speed is still preserved. Let's go have another look at some additional control we can put in. Notice that we have a 3mm drill, and while the machine may be able to run to 10,000 RPM, perhaps we don't want this drill to exceed 1500 RPM. Notice that we can assign a max RPM value directly into the tool. When I press OK, we now have a new note that instruction 16, again the calculated spindle speed is greater than the max RPM assigned in the tool in this case, and so that's been further adjusted. If we look at instruction 16, notice that the spindle speed is now limited to the 1500 RPM value we asked for, with plunge feed that's similar. That's awesome. It saves us a great amount of time. Let's consider what would happen if we were using feeds and speeds from the tooling database. We peek over at the Setup tab. Notice that Inconel is currently selected as the material for this part. When we go back to the drill cycle, we're going to change the technology over to general technology, and that looks up cutting data. Again, notice that this cutting data is going to overspeed the max RPM assigned at the tool. After we press OK, notice that again there's a new note that the feed and speed has been adjusted. If we peek at the whole cycle, we can see that the calculated speeds and feeds are also brought down to respect the max RPM, and feed is also similarly adjusted.